Hi, my name is Reagan, and today we're going to be doing Experiment 5, Physiologically Important Ions. In this experiment, we're going to be doing qualitative testing. Qualitative testing is a test where we add certain chemicals or compounds to a solution and then observe either a color change or precipitate formation that will show us the presence or absence of an ion in a solution. There are three types of qualitative tests that we're going to be doing today. The first is a precipitation test. A precipitation test is a test wherein we have an analyte in solution, we add a chemical, and then a white or some colored precipitate will form. A precipitate is a solid that forms in solution, and it will eventually, if left alone, fall to the bottom of the test tube as a solid. The next test is a color test or a complexation test, where we add a chemical to a solution and then a color is formed, such as a red color for iron thiocyanate, like we're going to show you today, or a blue color like for copper. The last test is a gas releasing test. This test is used when we add a strong acid or some other chemical to a solid, and if gas is released, we know that we have some sort of compound that would release that gas. So now that we've talked about the theory of this lab, we're going to talk about safety. Safety always comes first in the laboratory environment. For this lab, you need to make sure you're wearing your lab coat buttoned all the way up, you're wearing gloves, you're wearing pants that go all the way to your ankles and that cover your ankles entirely, and that you'll have closed-toed shoes. We don't want to have any skin showing below our lab coat in case we spill any chemicals. Any long hair needs to be tied back, and you also need to wear some closed goggles for this lab. Also in this lab, when we use ammonia hydroxide later, there will be strong fumes of ammonia produced, and we want to make sure that we don't smell the test tubes or be too close to the test tubes, as it might be kind of an irritant for your nose. For the first part of the experiment, called the precipitation test, we're going to be using four chemicals. The first chemical is 1% calcium chloride, 1% sodium carbonate, 1% sodium chloride, and 0.1 molar silver nitrate. We're also going to be using two test tubes for each experiment. One test tube which will have your chemicals added to it, and one test tube that will just have deionized water, so that way you can see what a negative test looks like and then compare your two test tubes. So for the first test, we're going to be adding 1 milliliter or about 10 drops of calcium chloride to your test tube. After we have added the calcium chloride, we can then add 20 drops of sodium bicarbonate to both test tubes. In this way, we can see what a positive result looks like and also what a negative result looks like. After we have added the sodium carbonate to both solutions, we can see that in our calcium chloride solution a solid has formed, and our distilled water there is no solid that is formed. This white precipitate or solid that has formed in this test tube is calcium carbonate. If we are to allow this to sit for a while or to centrifuge it, eventually the calcium carbonate would fall out of solution, and that's how we know it's a solid as opposed to just a color change. For the second part of the precipitation test, we're going to be doing a test with sodium chloride and silver nitrate. First, we will add 10 drops of sodium chloride, which is basically salt water, to a test tube. In our other test tube, we have, once again, 2 milliliters or a milliliter of distilled water. We can then add silver nitrate to both test tubes and observe the change that happens. So first we'll add it to distilled water to see our negative test. And as you can see, no precipitate has formed. And then we can add it to our sodium chloride solution. When we compare the two, once again we have a very white precipitate, or a very strong white precipitate that has formed in this test tube, while in the distilled water test tube, no precipitate has formed. The solid precipitate that has formed in this test tube is silver chloride. And once again, if we left it undisturbed, it would eventually fall out of solution and collect at the bottom. That concludes part 1 of this lab. Now we'll move on to part 2, which is complexation reactions that will form different colored compounds in solution. For this part of the lab, which is the complexation test, we're going to be using 4 chemicals again in 2 different reactions, just like our previous experiment. The first reaction will be using iron nitrate and potassium thiocyanate, and then we'll be doing a reaction using copper nitrate and ammonium hydroxide. Again, we'll need 2 test tubes for each experiment, and in one of the test tubes we need distilled water so that we can observe the negative reaction for these tests and be able to compare the 2. So to begin, we're going to be adding 10 drops of iron nitrate to the empty test tube. We can now add 10 drops of potassium thiocyanate to our distilled water solution so we can observe the negative reaction first. And then we will add 10 drops to our iron solution. If we observe the differences between these 2 test tubes, we'll see that the distilled water is still clear, but the iron nitrate solution has now become a very dark red or brown iron thiocyanate complex. This complex is not a precipitate because it's not a solid. So if we centrifuge this or let it sit for a while, it would not fall out of solution like the previous experiments would. For the second part of this part of the experiment, we'll be using a copper nitrate solution and ammonium hydroxide. Again, we have 2 test tubes, one empty and one with distilled water. We will first add 10 drops of the copper nitrate solution to the empty test tube. And then add ammonium hydroxide to the distilled water first to observe the negative reaction, and then to the copper nitrate solution. This reaction will produce an odor, an ammonium odor, because ammonium hydroxide is just ammonia dissolved into water. So we can now add it to our copper solution, and we will observe the color change that happens. As you can see, as compared to the distilled water negative, we have a much darker blue solution than we began with in the copper nitrate when we added the ammonium hydroxide. Again, this is a color change of complexation. It's not a precipitate, so it would not fall out of solution as a solid. For the final part of this lab, we're going to be doing a gas releasing test. To do so, we're going to be using sodium carbonate, which is similar to baking soda that you may have in your home, but has 2 sodiums instead of 1, and 3 molar nitric acid, which is a strong acid. I've put a small amount of sodium carbonate in this test tube, and we're going to add a couple of drops of nitric acid to it and observe the reaction that occurs. As you can see, a gas is released when I add the acid to the solid sodium carbonate. This reaction forms water and carbon dioxide, which is the gas that you can see disappearing from the liquid. This is a similar reaction that occurs when you add vinegar to baking soda or when you take an antacid because your stomach hurts. It produces carbon dioxide, which bubbles away, and this can give us some insight into what reaction is happening and what products are being formed. So now that we've seen the reaction and what solid was formed, let's look at the formula in your lab book and talk about how we represent solids from aqueous solutions in a chemical formula. So in the first one, we had calcium chloride in a test tube and we added sodium carbonate to it. And when we did that, we formed calcium carbonate, which was the solid, and sodium chloride, which stayed in solution as ions, similar to salt water. The calcium carbonate came out of solution as a precipitate, which is a solid that it forms in solution and will eventually settle out. And this is represented by a small s in parentheses that is next to the chemical formula for the compound that is a solid, which is the calcium carbonate in this solution. And then in the second experiment, we had sodium chloride in solution and silver nitrate. And when we added the silver nitrate to the sodium chloride, we got sodium nitrate, which is still in solution because neither of these compounds will form a precipitate together, that is. And we got silver chloride, which once again is a solid. As we saw, it was the very puffy, white, opaque precipitate that formed in solution. That concludes experiment 5, physiologically important ions, and how we can test for them using qualitative chemistry. If you need any additional assistance in your lab, please feel free to ask your TA and they'll be more than happy to help you.